Welcome to SIM-PAC Live, where the rubber meets the road. I'm your host, Jeff Matthews, and today I'm going to talk with wave energy pioneer and entrepreneur Ivan Voropov. My interest in wave energy goes back several decades. As a New Zealander living near the sea, I've always been captivated by the constant power of the oceans. Wave energy offers us an almost unlimited source of energy if it can be harnessed. It also offers a great buffer to the large quantities of variable renewable energy that we have coming on stream, and that we need to continue to come on stream in the future. So why is it that the wave energy industry is almost at a standstill? Last year, only about 1.4 megawatts came on stream. This is close to zero in comparison with wind's 17 gigawatts. Now, I appreciate Ivan coming on to the show, especially as I've told him that I'm going to ask him the hard questions. Welcome, Ivan.
Hello, Joe.
Now, wave power. First of all, I want to address the elephant in the room. And when we're talking wave power, I've been hanging out for wave power much longer than I have for solar and wind. In fact, my interest in wave power goes back about 3 decades. And we're still waiting, and you guys are getting left in the dust by solar and wind in terms of what the gigawatts of installed capacity. In fact, I think last year, wave energy amounted to newly installed was 1.2 megawatts or something, as opposed to gigawatts of wind and solar. And let's just address that first. Why is it being so hard?
Good question. Because there are only 2 or 3 main designs which were tested in many years, and none of them couldn't provide commercial power. There are a lot of existing wave energy projects based basically on the same designs or same approaches, and I wouldn't expect too much from this because people tried it before. Very similar design now, and why we should expect completely different result. 3 main things from my point of view. Wave, unlike solar or wind, where wind or solar delivering continuous input, a wave crest, wave consists of wave crest and wave through, and most of the designs using wave crest, like oscillating motion. And during the idle, during the wave through, device doesn't work, which, from my point of view, very big issue, because if you're using turbine, wind turbine or something like that, generating part expecting continuous input, and none of them likes interrupted. We know wave buoys, we know single oscillating water columns, we know wave dragons or something like that, and so far none of them couldn't provide continuous and commercially valuable power output.
And what about the difficulties of being in the sea? I mean, we talk about the almost limitless energy from the sea and the motion of the sea, but we all know the sea with its corrosive nature and its power. How many of these types or these technologies or efforts have seen them, sunk to the bottom of the sea, so to speak, because they couldn't cope with the moving parts in such a volatile environment?
Exactly right, Geoff. Yes, salt water is just, I wouldn't say it's a big issue because there are a lot of solutions to fight it, to fix it. But yes, moving parts, unpredictable or wide range of wave parameters, because in a windy weather or storm weather, wavelengths getting longer, normal or calm weather, wavelength is shorter. Wave height also depends on wind. It's continuously changing environment, and it is a big challenge to design something which will work well and which will provide commercially valuable amount of power with in such various environment, and will survive stormy weather and will still be efficient in a calm weather as well. It's a challenge.
Yes, and there have been lots of investors who have lost their shirt, so to speak, in investing in wave power. Things have gone wrong. We know one of them did end up on the bottom of the sea, and no one's quite seemed to make it work. There's a few operating, but they would be well subsidised, and they've been in place a while, but they haven't been added to. It's not like this is a rapidly expanding industry, and so do you find that investors have been gun shy because of the fact that, you know, repeatedly over history and every couple of 10 years, you know, they lose their shirt, so to speak?
Exactly. Yes, I agree, and I think I understood in investors, because why we should invest into something which couldn't deliver at least one more or less appropriate solution which can generate a commercially valuable power. And so far, none of them were successful.
Yes.
That is the
okay,
reason.
so if you could. Yeah, let's take the viewers through the sort of. There's basically 4 different designs or names they've given to 4 different engineering routes, because that's the other interesting thing about wave energy, is there are distinct engineering pathways to try and get energy. There's 4 main ones. You could probably say there's 6. I heard a professor from a US university that has a wave testing facility say there's as many designs as there are engineers. But if you could help us, take us through the main different designs so we can understand the complexity of the problem.
Most popular is oscillating water column, because if you check a wiki, you can find WaveGen, which were like a 30, 40, something like that, the end of 80s or early of 90s. And I like them because it was the first wave energy project which honestly published performance and test results. And maybe I'm missing something, maybe I'm mistaken, but if I'm right, it was like a 5 or 6% efficiency from wave to wire in a perfect windy weather. Basically, it's not nothing. And WaveGen honestly saying it wasn't successful.
And was that a water column?
Oscillating water column, yes.
The WaveGen?
WaveGen, yes.
Yes. Now, an oscillating water column, yeah, correct me if I'm wrong, that means the wave comes into whatever chamber and then pushes air, displaces air and pushes air, and the air actually turns the turbine, which generates electricity. And it can either push it outwards or it can actually suck it back in, because it's created, as the wave goes down, it creates a vacuum, pulls the air. So technically the moving part is a wind turbine. And the water is pushing the air in and out past the wind turbine. That's an oscillating water column. Okay.
Yes.
And then what's the next one?
A single point absorber, which can be buoy or anything in the water. Most of them using the same oscillating motion, but unlike oscillating water column, they use some sort of float which connected to the generator, and that oscillating motion up and down. Probably some of them using magnets, some of them using something else, but that is a basic concept. A single point absorber using wave crest to generate power.
Right, so that means that the buoy on the top is pulling a cable or something up and down, past something else like a magnet, and it's pulling it in and out, and it's generating electricity.
Yes.
Right.
Or aqueduct, another famous project. Yes. Aqueduct is popular project. Audience can check wiki and find a lot of articles about aqueduct. It's a single point absorber.
Yeah. And the third sort?
Wave Dragon. It's a completely different story. Wide floating thing, which catching approaching wave crest and accumulates water in a container, and when wave crest passing along away, water start falling down, and little turbine or water turbine start producing power.
Right.
Yes.
So the up and down flow of the water is turning a turbine. And then I think the last one, I don't know.
They're catching a wave crest. They're catching wave crest, accumulating somewhere in a container or something, and after this they're using that water to produce power. Basically, that is the three main ways to do that. Yes.
Yes, and there's one more, and it's sort of more anchored to the bottom of the sea floor, and it's using the motion within the water column, which can run really deep, 200 feet deep. Yes. And it uses the motion, back and forth motion, in some way to capture that motion to capture electricity. So
yes, it's a variation of submerged aqueduct. Yes. Yep.
Yes. So for the viewer, that all of these are very motion intense, and because we're dealing with something big and heavy that's moving, and we're trying to capture the energy in that something big and heavy that's moving to try and spin something or do something to create electricity. So now let's talk about your technology, your approach. How does yours work, and the journey that you've been on, and where you are now? Because I assume that you're looking for investment money to ramp up and try a commercially viable at scale model, and we're hoping the best. By the way, I think we've got all this energy. We've got to try and find how to use it. So tell us about your particular technology.
We learn before doing anything, before even starting any prototyping, we learned all existing approaches, and I think we learned and we understood why they were not successful. And as I probably mentioned it before, the main reason is creating continuous unidirectional input for turbine or for generator. We don't exactly, you mentioned a lot of mechanical parts, especially in submerged devices. From our point of view, it makes CapEx too big, which obviously will impact to commercial performance. And we decided don't submerge anything. We decided to keep everything above the water as much as we can. And from our point of view, oscillating water column chamber is a best possible approach because it's simple. It doesn't have any mechanical parts, and it perfectly converts motion of the wave crest into the oscillating water motion inside the chamber. It's simple, reliable, and inexpensive. To solve this unidirectional flow, we already learned that single oscillating water column doesn't produce unidirectional airflow. Air goes out and air goes in. Basically, there are special turbines which work with both with bidirectional airflow, but they're not such efficient as a regular wind turbines. So to solve this issue, we decided to build a long line of chambers. And each chamber has inlet and outlet flap. Basically, we built long air pump, because chamber can be considered as a cylinder, and oscillating water inside is a piston. And each air pump, each cylinder in air pump has inlet and outlet valves. So we built the flaps, and if you check our website, you will see how it works. And when we build multiple prototypes, initially we worked together with Peter Nielsen and Tom Bullock in University of Queensland, and the students played a lot with our prototypes. And as soon as we were sure that everything works well, we built 30 meters long unit and tested it in Moreton Bay. We recorded very promising data. We recorded 32% from wave to wire. And considering that wave mill chambers is relatively inexpensive, we think that wave mill can compete conventional power plants.
Right, and the one that you've got in Moreton Bay, it's been there a while now, and is it still generating? Is it still working? And what sort of generating capacity have you got out of it?
It was small. It provides enough power for 2-3 households. It was a prototype. It wasn't a commercial unit, and we lost it. We lost it. It was broken in half. According to insurance report, they surveyed everything. We received reports saying that it's a combination of poor labor, poor welding, and poor naval architectural design. So basically, it wasn't fault of technology. Yes. Technology is still good, but we need to find better welders and probably better naval architect.
Yeah. The marine side let you down, not the energy generation side.
No.
So, and look, we will put a clip, in fact, into this video to show people how it works. And so you're at the stage now. There's a lot of money going into renewables. There's massive growth. One of the things that and even since you and I first started talking about coming on the show, the installation of wind, especially in Europe, is hitting some headwinds. And essentially what the issue is that solar panels are still having a learning rate of, a couple of years. That means every 2 years you get twice as much solar power as you did for the same money as 2 years ago. And I've seen some indications that we haven't even seen the big energy efficiencies. There's a university that believe they can get 1,000 times more electricity out of a solar cell as they're doing today, 1,000 times. But wind went through a learning rate that was really, really good for a while. But essentially, they were just building bigger turbines. There was a little bit of efficiency in blades and low speed, but essentially they've hit the cap on that. And because it's not a computer chip that can keep improving, they've hit a cap. And so the cost overruns of installed wind power is now pushing the price up. And a lot of these projects that they won auctions, they can't deliver it. They can't build them for the cost of power that they were going to generate, just because it's supply chain issues. And as I said, they're starting to hit a design cap. They're starting to bump against the ceiling. And unless there's another big breakthrough, they just can't get more efficiency by building them bigger. My point being is that maybe Wave, and this was one of the big the big consultancies saying it's going to be the next frontier in renewable energy. It probably started as one of the first, by the way, because I think wave power was first, the first machines were patented in Scotland in 1979. But maybe its time is still in front of it, because the cost of offshore wind turbines is not going to look that rosy anymore. It's actually looking like it's going to go up, not continue to fall as it's done over the past while. So there might be a turning point in there. And do you think that where are you in terms of cost? Do you have any idea in a megawatt hour cost scenario?
Very close to our current rate of offshore wind. Very, very close. We contacted large marine engineering companies, and they provided us like a rough estimation for 10 megawatt unit, and we got figures basically the same as a 10 megawatt set of 10 megawatt offshore wind turbines. But unlike wind turbine, it's interesting economics, because capex very close, operational cost similar, but generating capacity much higher, because nature of wind, you can get 20, 30, 35%, waves 80, 90. So basically, return on investment significantly more. Yes.
Yes, because that's the thing. Even for the untrained eye, you look out there and one day and you think it's flat. It's actually not. There's still wave motion out there. And so you've got that generating capacity. So, which is what we need. If we are filling the grid with variable renewable energy, we need stuff that's more reliable and dispatchable, and we're not going to fill it all by batteries. So now I'm deep dark in my history. I was the founder and CEO of a salmon farm, and so I've had a bit to do with anchoring rafts and moving bodies of water. But I would have thought some of these fish farming operations, currently they all use diesel generators, or even petrol generators, incredibly polluting things. Is any of them shown interest in your wave technology? Because they are about anchoring rafts out at sea. And I know that aquaculture space is limited, but I'm sure that having power generated alongside their rafts, their fish rafts, would have been quite an attractive proposition.
Exactly right. Wave mill unit itself, you can consider it as a aqua farm. So basically, yes, wave mill is an aqua farm, because it's set of chambers. It's set of chambers, and as soon as we put our prototype in the water, in the Moreton Bay, all this aqua life start using it as artificial reef, because these chambers, they can hide themselves, they can find something to eat, and to turn it in an oyster farm or fish farm or whatever, it's easy, because you can use chambers. All you need just to keep some water inside chambers, or you can just cut some of them off, or we can provide different designs and adopt it for customer needs. We can basically, if customer give us required power supply, we can design it, and that unit will provide exactly want to have on board. It's yes, and another nature is basically using, if it's small unit, it uses single point mooring. Large unit probably will have a multi-point mooring, and usually aqua farms, they're not going to the deep water. What I'm saying, it should be a relatively inexpensive exercise for them. The cost of unit will be close to the cost of things that they're using right now.
Yes. And then you've also got, I know the US Navy has a facility in Hawaii to test wave power, because they're looking at it for their expeditionary forces. If they go into somewhere, they want to be able to drop something over the side and generate electricity from it. So, but it doesn't seem as though anyone's cracked it in their eyes, so to speak. But they still offer that ability for commercial enterprises to test their wave generators in those Hawaii waters. Ivan, look, thank you very much for coming on the show. It's been difficult to get somebody to come and talk about wave power, funny enough. I'm sure that if I wanted to have somebody about solar or wind, I would have had dozens of people wanting to come on the show. And I was genuinely interested in trying to work out whether it's going to be wave energy is going to be off the table, or whether it's something that needs to be put on the table. And here's hoping that your time is yet to come.
Yeah, it would be great if you will have that chance. Yes. And thank you very much, Joe. It was a pleasure to be here with you. And we look forward and be ready for new adventures.
Yeah, thank you. Thank you. And I'll put your contact details into the video, so if anyone wants to get a hold of you, they can.
Yes.
Thank you very much, Ivan.
Thank you.
See you later.
Bye.